Imagine a world where you can send money across the globe instantly, without involving banks. Track the origin of your food right from the farm to your plate, or even prove ownership of a digital artwork, all with complete security and transparency. Welcome to the fascinating world of blockchain technology. But how did we get here? This is the second video in our blockchain series, where we'll uncover the remarkable journey of blockchain technology, from its conceptual origins to its revolutionary applications today. This video will show you how blockchain has evolved into one of the most groundbreaking technologies of our time. Let's dive deep into the past to understand how blockchain came to be and why it's reshaping industries globally. By the end of this video, you'll not only understand its history, but also appreciate why blockchain is called the technology of the future. Right. 1. Before blockchain, the early foundations. To understand blockchain's evolution, we first need to explore the foundational concepts that came long before the term blockchain was coined. A cryptography, the building block. 1970s. Blockchain relies heavily on cryptography, the science of securing communication. Think of cryptography as a secret code that only you and your friend can understand. This concept gained significant traction in the 1970s with the invention of hash functions. These are like digital fingerprints. For example, if you write a letter, a hash function can create a unique code for that letter. If someone changes even one word, the code will change, ensuring data integrity. Public and private keys. Imagine having a mailbox where anyone can drop letters. Public key, but only you can open it with your unique key. Private key. This became a cornerstone for secure digital communication. B. Decentralized systems. The Internet's role. 1980s or 1990s. With the rise of the Internet, people began looking for ways to share information securely without relying on a central authority. Let's say you're playing an online game with friends. If the game server crashes, everyone's progress is lost. A decentralized system ensures that even if one part fails, the rest keeps running smoothly. These early concepts of cryptography and decentralization set the stage for blockchain's development. The first glimpse of blockchain. 1991. In 1991, Stuart Haber and W. Scott Stornetta introduced the concept of a secure chain of blocks to timestamp digital documents. What problem were they solving? Imagine you're a photographer uploading your work online. How do you prove that you took the photo first if someone else claims ownership? Haber and Stornetta's system ensured that once a document was timestamped, it couldn't be altered without leaving a trace. Their idea used cryptographic techniques to link records in a chronological order, creating an early version of what we now call a blockchain. However, their work didn't gain much traction at the time. The birth of Bitcoin. Blockchain finds its purpose. 2008. Fast forward to 2008. The global financial crisis shattered trust in traditional banking systems. Enter Satoshi Nakamoto, the mysterious creator of Bitcoin. Nakamoto's white paper introduced blockchain as the underlying technology for Bitcoin, the world's first decentralized cryptocurrency. How does Bitcoin use blockchain? Let's say you're playing a game of Monopoly. Instead of the banker keeping track of transactions, every player records them. At the end of each turn, everyone compares their records. If all match, the transactions are verified. Blockchain works similarly. Decentralization. No single entity controls the system. Transparency. All participants can view the transaction history. Immutability. Once recorded, data cannot be changed. This innovative approach solved the problem of double spending in digital currencies, ensuring that the same Bitcoin couldn't be spent twice. The early years of blockchain. 2009-2015. A blockchain and Bitcoin. The early connection. Initially, Blockchain was synonymous with Bitcoin. People thought it was just a tool for cryptocurrencies. Think of it like the early internet, which was primarily used for emails. Few could predict its broader applications. B. The rise of altcoins. As Bitcoin gained popularity, other cryptocurrencies like Litecoin and Ripple emerged. These were collectively known as altcoins, alternative coins. Each tried to improve upon Bitcoin's limitations, such as transaction speed and energy consumption. Ethereum, expanding blockchain's potential. In 2015, Vitalik Buterin introduced Ethereum, a blockchain platform that went beyond currency. Ethereum allowed developers to create smart contracts. Example: imagine renting a car. With a smart contract, as soon as you make the payment, the car unlocks automatically. No middlemen needed. This marked the transition from blockchain 1.0, cryptocurrencies, to blockchain 2.0, applications beyond currency. Blockchain 2.0, revolutionizing industries. 2015 present. Blockchain began transforming various industries. Here are a few examples. A. Supply chain management. Have you ever wondered where your coffee beans come from? Blockchain enables companies to track every step of a product's journey, ensuring transparency and authenticity. B. Healthcare. Imagine visiting a new doctor and instantly granting them access to your medical history securely. Blockchain makes this possible while protecting patient privacy. C. Voting systems. Blockchain can eliminate election fraud by creating transparent and tamper-proof voting systems. Every vote is recorded securely and cannot be altered. D. Financial services. DeFi, decentralized finance. Gwash, DeFi, allows people to borrow, lend, and trade assets without banks. Think of it as a peer-to-peer lending system where trust is automated through smart contracts, NFTs, and the digital revolution. In recent years, non-fungible tokens, NFTs, have gained immense popularity. These are unique digital assets stored on a blockchain. For example, if you buy a painting, you get a certificate proving its authenticity. NFTs do the same for digital art, music, and even virtual real estate. 7. Challenges facing blockchain. While blockchain holds immense potential, it's not without challenges. Scalability. Can blockchain handle millions of transactions quickly? Energy consumption. Some blockchain systems require significant energy, raising environmental concerns. Regulatory issues. Governments are still figuring out how to regulate blockchain-based systems. In the future of blockchain, experts believe blockchain will continue to disrupt industries. Potential applications include education, verifiable digital diplomas, real estate, simplified property transactions, space exploration, tracking satellites and resources securely. Imagine buying a house where the entire process, from payment to ownership transfer, happens on a blockchain in minutes. Conclusion. The history of blockchain is a story of innovation, resilience, and endless possibilities. From its humble beginnings as a concept in the 1990s to its role in powering cryptocurrencies and transforming industries, blockchain has come a long way. In our next video, we'll dive into key features of blockchain: decentralization, transparency, immutability, etc. Unpacking the mechanics behind this revolutionary technology. Make sure to stay tuned because the best is yet to come.